Want me to turn on the full screen now?
Hello, hello. It is astronomy time again here at United Astronomy Clubs of New Jersey. I'm here with Michael Dean Lewis, a NASA Solar System ambassador, presenting Perseverance, The Exploration Begins. Uh, this program is about Perseverance having landed on February 18th, and after the 6 month travel, we're discussing entry, descent, landing, telemetric data, and some of the new technologies and new experimental objectives and future connected missions. Michael has been an active NASA Solar System ambassador. He regularly participates in teleconferences presented by NASA scientists and loves to present programs to a very public audience. He lives in Hillsborough, New Jersey, and is a return guest speaker here at United Astronomy Clubs of New Jersey. And with that, we welcome Michael.
Thanks, Kim, and thank you, Jeff. And I hope our audience is ready to see some exciting material that you've not seen before, and that it's a background of the Perseverance journey beginning last July 30th. And of course, you've seen the title. It is Perseverance, The Exploration Begins. Once again, thank you for inviting me. So let's begin with the first part of the journey. Well, it was the launch, right? But actually, there were several years before where the Perseverance was being built. It was first proposed. I've been with NASA Jet Propulsion now for 25 years. This will coming up my 25th year, discussing with Ron Balke and others at JPL. And I can tell you that there's a lot of work that's done before we're going to see some of it. Anyway, get to it. The Mars programs began, of course, as you know this, back in the 60s, and we continued through the 70s, 80s, 90s. But in the late 90s, we had two Mars explorers that failed after the first one, the Sojourner, and that was the Mars Polar Lander and the Mars Climate Orbiter. After those two disasters, there was a revamping and redesigning of how NASA would conduct their space missions, and including, of course, with that were the Mars missions. And subsequent to that, we've had several successful Mars orbiters and landers on Mars. And this is just continuing that saga. And I'm proud to present what we're going to see. All right, so this is a picture of the Mars 2020. At the time it was called, at the launch in July of the past year, 2020, July 30th. A lot of hoopla, a lot of excitement, and everything went according to plan. As you can see by this slide, the first launch window would occur on July 30th at 4:50 a.m. PT. That would be Pacific time, and on those of us on the East Coast, it was 7:50 a.m. E time, and it was launched exactly at that time. What an exciting launch it was. And we waited 208 days, and Perseverance landed this past Thursday at 3:55 p.m., which was estimated to be at 3 p.m. Eastern Standard Time. That's 12:55 PST. And so a flawless launching, en route, journey, and landing. Now we're going to get through a little of the multimedia that's available. If you go to the mars.nasa.gov website, and you will see the multimedia resources. If you take photo snapshots of each one of these slides, you'll be able to access many of the points where you'll get more in-depth insight into the Mars 2020 mission, the Perseverance. And I've heard that some people call it Percy, You can read and see more of it on Twitter and Facebook. And you can see here, you can look there with at NASA Persevere, and on the Facebook page, it's also NASA Persevere. So let's get on with the launch. The launch occurring July 30th. Eyes on the solar system. Here, I'd like to show you a short uh, look at our solar system. Those of us that like to look at the nighttime sky, and you can see through the Eyes on the Sky program where Mars and Earth are at this time with the other planets, Jupiter and Saturn. Remember, we have a mission from NASA orbiting Jupiter, the Juno mission. We did have a very successful mission to Saturn, the Cassini-Huygens mission. And of course, we had the one that left our solar system, the two Voyagers, the Pioneers, and most recently the New Horizons that visited Pluto and our first Kuiper Belt object. All right, but anyway, we can look at Eyes in the Sky, and I want to show you where Mars is located relative to Earth at this time. And you could see here in Earth is in blue, and you could see here in red Mars. You could see where the stereo, the ahead and the stereo, they're looking at the sun. Been there for about 10, 11 years now. And they've been looking at and protecting us, warning us. And we can also see the two asteroid Ceres, and we can see Vesta that have been visited by the Dawn mission. Very successful program where we did orbit both Ceres and Vesta and mapped it very closely. But anyway, let's get on with Mars.
Hey,
Uh,
Michael,
yes,
it looks like we have a slight problem with your screen. Are you in slide presenter mode?
I am. Yes. You're
Okay,
not seeing the slides at this time?
uh, what slide I'm currently on, it looks to be the intro slide.
Oh, okay. We've not moved on from the intro?
Yeah, and it's not actually in the slideshow. It looks like it's in the PowerPoint presentation itself, like the application.
Okay, so you're seeing the Mars mission only, the Perseverance, the exploration begins site?
Yes.
All right, so in order to get it present online, I guess I got to do this, right? So I have to do the online connect that way? It'll,
You should just be able to press slideshow, the view slideshow.
okay, I had that already, but let me see here with the view. Yeah. Thank you for telling me. I'm sorry that
Nope, not a problem. This is
it
why we
see.
watch on this end.
Yeah, well, people can't see it. That's so slideshow, resume slideshow. So do you see the recording at launch time? Eyes on the solar system?
Do you happen to have two screens?
I wasn't showing two screens, but maybe. Um,
Because we are still seeing the PowerPoint application on the main screen.
okay. All right. So you're seeing the power, this one, and then this one?
Okay, now it just switched to the slide of the Mars 2020 launch,
But it's not in
still in
the
the
slide.
PowerPoint application, not as just the slideshow.
Okay, so I can see here slideshow above. You can see that, yes. And it just, it starts slideshow from current slide. Do you see the slideshow
Yep,
now?
there we go. Now it's good.
All right, so you do see the 2020 launch. Let's get to the
Yep,
exact,
and now we're on the launch window slide.
okay. Now can you see
Perfect.
it? Everything good? Launch
Yep,
window?
that
Yep,
appears
there
to
it
have
is.
sorted the problem. Thank you. I
Oh,
will go back muted now.
sure. All right, so here is the multimedia resource website that I was talking about earlier, and you can see several of of the things you can download. You can make the sticker, you can learn about the ingenuity, you can build the 3D model of the helicopter, and there's a Perseverance poster you can print out. Lots of resources. All right. So, and here are the two resources for the Twitter and Facebook. that were mentioned earlier. And here we have the launch. This is New Horizons, actually, back in uh, January of 2006. I show this one because it was a nail biter. If we had missed the window to New Horizons, it would have been another year tacked on. And then here was the eyes of the solar system, which I was looking at earlier. I'm going to show it again. And Kim, if you would just pipe in and let me know if you do see this site. Does everyone see this site?
Currently, we do not see the site.
Okay, you do not see that, so I'm not going to go there. All right, so let's come back. And you see this now, is that correct? Do you
Yes, it
see?
just switched to a view of a something orbiting or leaving Earth.
Yes, leaving Earth. This is Perseverance leaving Earth. It's all right. Eyes, the previous web that you just saw, the Eyes on the Sky, is a great resource to find out where the planets are located and where the satellites are located um, from NASA, up to date, current. All right, so here's Perseverance leaving the Earth's gravity. Well, almost Earth's gravity. Remember, gravity never goes away, even if you're millions of miles away. But anyway, the next picture here shows clearly what's going on that many may not realize what's happened, why the landing occurred when it did, and how is that affected by what the mission entails. And here you're seeing a picture of the Earth to Mars annular position. And of course, tonight in clear skies on the East Coast, we can see, we were able to see Mars clearly and still can, but at 7:36 tonight, it was in the west southwest at about an altitude of 55 degrees. And I hope that some of you, I know that this is an astronomy presentation, have been looking in the night sky. Well, what you're seeing here is a downward, we're looking at the months of Earth in blue orbiting the sun. And as you know, or if you don't know, the Earth and Mars, they orbit in an elliptical uh, way. That's an oval. Now, Earth has a slight oval, and Mars has less of an oval. But regardless, the positions of where the Mars launch occurred on Earth is in blue, and I kind of dillied out. I made a mark here in blue at the end of July, and you can see there at that point, July 2018. There's a line extending from it. That's just pointing out that that was where it was at 2018, but also in 2020. So this is where the launch window occurred. And then the mission, of course, went until February 18th, which is located near the bottom of its southwest here. And you can draw the line. There's a line of apsidus, and this line is the major elliptical axis. And so this is where you can read in May that Mars is now. So the seasons on Mars are a little longer than they are on Earth because it takes approximately 2 years for Mars to orbit the sun as opposed to our 1 year. And that is when the lander has landed. So here we are showing that the landing has occurred on Mars where the weather is like spring. But of course, spring on Mars is very cold. It's still going to be 30 degrees below and maybe warm up a little bit more towards freezing during the day. But very cold climate. That's one of the things we have to take into mind. All right, so here we're going to look at Mars as a global view. And we could see many of the places on Mars that have been looked at and investigated. The place that we're most interested in is in the top right, called Syrtis Major. And those of us who look through the telescope at Mars have seen Syrtis Major. Here we have the Huygens crater And you can see the South Polar Cap, North Polar Cap, and some other Hellas Basin, Margaret Terra, Terra Meridiani, Schiaparelli Crater, and Arabia Terra. So we are most interested in Certa Major. So let's further go into Certa Major. And here's one of those made by the Mars Global Surveyor, which has been orbiting Mars since 2003. Still actively taking pictures. And this is, of course, a picture of Mars colored. This is not what actually Mars looks like. As you saw in the previous slide, that was a real color photo. This is highlighting the gravitational anomalies that are occurring on Mars that was measured by the Global Surveyor. And you can see here Syrtis Major, and to the northeast of it is Jezero Crater. And here's the Syrtis Basin. We're going to look at that again from a real color slide. And here again, you can see here Syrtis, and there's the plain. And then we have in the upper left, we have Jezero Crater. Approximately the arrow is right here in this region. Now, I want to just go further with this slide because we're going to see why Jezero Crater was picked. You see, this is as we've learned to improve our technology, our computer applications and such, we've also been able to improve our navigation and our landing precision. And this is a very good picture behind the scenes. Now, don't be lost in the dashed lines or the words. What I'm more interested in is checking out the background. I want you to look at the background first. And this is Jezero Crater that you're seeing. And it is approximately 7 kilometers in width, and it 7 kilometers in radius, excuse me. So it's about 15 kilometers in width, and it has 2,000 meter height cliffs here, 2,000 meter cliffs. But you can see here where the lander has occurred is a place where there was a rift. There is a gully right here. A little delta river flow is believed to have occurred here, and you can even see the river bed. This is why I wanted you to focus on here, where my arrow is, of where the water was once believed to have flowed into Jezero Crater. And so we're looking for life. The primary mission of Perseverance is to find life, astrobiology. And you can see now, look at the dashed lines if you like, but a great picture here of what we can see from the Mars Reconnaissance Orbiter, which I have a sweatshirt on, involved with that at the time, giving several presentations. Fascinating mission, and it's still working because of the HiRISE. That's the high intensity scientific experiment. It's a great imager, super telescope. So without the new landing site, without the new landing site navigation, we would not have been able to land on Jezero Crater with the precision. We're going to get into that in just a moment, what kind of navigation was involved. But the MSL is the Mars Surface Lander, which is the previous mission named Phoenix that occurred just before we had this latest mission. But we haven't had a rover on Mars since 2012, and that's finally over with the successful landing. We just have to wait now a couple of weeks. Some of you are going to ask about that. There's approximately a 2-week checkout instrument time period where the JPL are working 12-hour shifts. My niece is actively working right now at Pasadena on this mission, and she is doing this 12-hour shifts on and off for I don't know how long, but that's what they're doing. So let's talk about the navigation. Here's a great picture of video showing how the Mars 2020 Perseverance made its new landing technique. There are lots of pictures being taken. Everything is being computer simulated. Remember, this is a self-autonomous landing. That is, that everything has to be controlled from the rover itself, from the landing module, because it takes approximately 15 minutes for a one-way signal to get to Mars and back. And so we're looking at the new landing technique to prevent what happened with the Mars Polar Lander, which we still don't know where it is. Okay, so the EDL, which is Entry, Descent, Landing, a lot of major improvements since 2012. But we were able to use many of the parts from the Curiosity rover, which was the 2012, into the new mission for Perseverance. So it saved some money. Here's a video, quick little video of how the sort of team effort, approximately 20 individual scientists.
Hey, Michael. Michael, can you hear me? Because your microphone just cut out. Michael, it appears you have muted yourself. I'm live. Michael.
For some reason, it doesn't allow me to keep on the mute. And so let's get back to it. Sorry. All right. Are we on the PowerPoint again or no?
We are back in the PowerPoint mode, and currently I'm looking at the Mars 2020 launch slide.
Oh, okay. So we went back to the launch side.
Yes, we are no longer in slideshow presentation mode. We are in the actual PowerPoint app where I can see all the slides.
Okay, let me change that real quick. So we'll go to start the slideshow again. And from current slide, how's that? Okay, we'll get through. Is that better?
Yes, and now we are back with the helicopter.
Okay, I'm going to go through. I'm going to fix that out. All right, I don't want to be unmuted again. All right, so here we go. Here is where, this is on the base of the helicopter. This is actually the camera that was used. There were several cameras actually, but here they are picking up the signal and looking for the best site. All right, so that one shows that. And then here we have the slides of the TRN, which is the Terrain Navigation System, the Terrain Range Navigation System, where the different pictures are shown. On the bottom right, you're going to see this is the furthest away. I can show this. This will not mute me out. But as you can see here, as the Perseverance, the lander, as it was descending, it was constantly sending itself pictures of the terrain because it's not able to use a GPS. This is on Mars. We have no GPS satellites at this time orbiting Mars. And so the only way that the navigation can be done, and this is the newest system, this was just introduced for this. And so the success of the rover here in its landing has brought about many, many new, and I'm sure that they're looking and tweaking ways that it could be even further improved. So this worked great. And as you can see here, the TRN in Death Valley picked up quickly where there were safe sites in green, and then blue are even better sites. And then we have the red sites where danger in orange. So color coded, but of course this is just for our purposes. This is sent to the onboard computers on Perseverance so that it would navigate correctly to the planet, which it did. Okay, so let's get on with it here. To the data improvement and the transmission. Okay, so we're going to keep improving the data. We have great storage here. We have gigabytes of memory, and we can now use these pressure and heating sensor and processing units to prevent things from happening. That is, from things going wrong. Remember, the clean room that they have is similar to the ones that are used in Silicon Valley in making our chips. And so we use this as well. And we have the cameras. There were a series of cameras, as you can see here, showing our 6 of them, and that they each are able to have a down look, and that was what was used in order to gain a successful landing. And so you could see here the different things. Now, I'm going to show you some videos after this, but this is really behind the scenes. This is what it is. The public, most of you don't really get to see behind the scenes and what's going on. You just want it to work, right? But those things that you want it to work have to be tested, retested, and tested again under very harsh conditions because of the temperatures at Mars. And so you can see here the different, the parachute structure. The spacecraft is entering at 12,000 plus miles per hour and has to be slowed. And then that parachute has to work, it has to deploy, and then there have to be several other steps that we're going to look at in a few moments. Okay, so the reason that we've been so successful is because of the prior successful missions to Mars. And we just continue are improving on the ways that we can land on other planets, not just Mars, but we're now looking at going to Europa and having an explorer there. But let's keep it on here, where you can see here where the MSL, the Phoenix, was able to gather information on the surface gravity and where the spacecraft could be accelerating more than at other places. So the timing of the entry onto the planet, this is what happened with the Climate Orbiter. No more of those missions that will fail that way. Climate Orbiter just skipped out like a stone on the water off of the atmosphere. 2020, 2000, one of the down moments, late 1999 of our program. But anyway, here we are back in success mode. Of course, we test all over the place, and one of the places that was tested for the parachute was done at Wallops Island, off of the southern tip of Delaware, Maryland, near Assateague Island. Okay, so here we are, supersonic parachute testing at Wallops Field, and again, that worked very well. All right, so we'll go on. We'll show now the EDL animation, which I'm glad to present to you, very happy to present. And we're going to look at it in a different way than what was presented, the shortcut method. This is actually showing what's going on if you read carefully. The altitude is at this point, about 100,000 kilometers away. And we're entering and we're getting down to a speed. We've got a speed of about 5,000 meters, which is the 12,000 miles per hour. The spacecraft is still accelerating. The Mars atmosphere is not able to provide a lot of braking. As it gets close, also you have to be careful of the heating. So we're getting closer, closer. This is exactly what happened on the February 18th. And here we are. You could read what's going on with the speed and the fuel consumption, real important. Again, accelerating, decelerating, decelerating. Okay, and decelerating. The rockets fire to readjust, and we have the landing zone, Jezero crater in the distance, and here it comes. We're traveling further, in, there it goes. Final deployment above. And we're continuing to descend. Altitude now at about 13,000 kilometers. Okay, we're looking at the deployment of the chute, which occurred at 11,000. Okay, and now we're coming down. The speed is about 200 miles per 450 meters per second, slowing the parachute deployed correctly. And now we have the breakaway from the heat shield no longer needed, and we have the deployment of the main body. So main body continues to descend. You can see the colored cameras now looking, each one of them searching for the site that will provide safety and close enough to that valley region that we were looking at earlier. All right, so at this point, we're at about 5,000 meters. All right, we're continuing to descend. And slowly searching. Almost there. All right, 4,000 meters. Okay. You can see the hazard lights. You can see the red regions. That's definitely not where we want to land. Speeds drop now to about 150, 200 miles per hour. Dropping again. We're now at 2,000 meters. We're almost a mile above. Now we are a mile above, 5,000 feet. It's all in meters. So this one's showing kilometers, but it's actually meters. And you can see that we're now 900 meters, 9 football fields above. Here we go, 500 coming down. Speeds drop to less than 100 miles per hour. All right, dropping further. And we're only 100 meters or so. Now it's 70 meters above, 50, 30. The rockets were deployed. And then the rover is on an umbilical cord, drops to the surface. And we're at 7 meters, 6 meters, 5, 4, 3. This took about 15 minutes to reach Earth. There it is right there. All right, so that's a picture of the deployment showing the reality of what happened. Now we'll show what the public saw that was press released a couple of days ago. So I don't want to have the mute cut out, but let's see what happens now. Okay.
Michael, it appears that once again the video has muted you. Michael, can you hear me? You are still currently muted.
Got it right this time. Okay, I see what happens. There's a cutoff whenever we play the video. So we saw the video before of the more technical aspect. Now here's what the public saw. I know you will see this in just a moment. All right, so here it is. Let me replay it. This is what was seen. You can download this off the internet. It is available on the NASA website. The others, unfortunately, no. There you have it. Successful deployment. That was the quick landing. I hope some of you have seen the excitement as the signals came back showing success. All right, so here's some other, when you do play that, you'll get some other information that's available. Okay, so let's go on. This was a picture that was captured by the Mars Reconnaissance Orbiter with a high-rise telescope orbiting, and this clearly shows the Perseverance descent to Mars. Quite a remarkable picture. In the upper right-hand corner, you can see the parachute deployed, and you can see the spacecraft underneath as it's landing. And in the background, you can actually see Jezero crater. So that's pretty cool, right? Anyway, remarkable. Here's a picture of the Perseverance landing during the descent stage. This is the umbilical cord you can see from the bottom attached to the parachute system, and to make sure the tether and everything's aligned to keep it level, to keep the spacecraft from tilting side to side. This is the first time that this landing system has been used, and it has proven so far to be a success. Let's just hope that all the instruments will be working. We'll find out in the next couple of weeks. And this is the one this is the first color image from Mars, from Perseverance, from the backside, underneath cam. This one has been in the papers. This one was shown, and very wonderful to see that. And I'll show you one more that was shown today that we got from JPL. Of one of the wheels has a camera beside it showing the sand and the topography of the soil, that landing area of where the Perseverance, the rover, has landed. So there we are. The wheel, those are the wheels in the forefront. Now, those wheels have provided quite an interesting story that we've learned from Spirit and Opportunity and from Curiosity. So there's been continuous improvement in the wheel design to prevent any further delay with having, like, for instance, Spirit was stopped in its tracks. It found a moist spot on Mars, and it was quite a while before we were able to remove it, to get it out. A lot of time spent doing that. Anyway, we'll continue here. I do want to show the Jezero crater flyover and where the Perseverance, the rover, is going to travel. Now, I'm hoping that this will work. So, Kim, please let me know if it doesn't work as it should, okay? Because if I click on it, I'm concerned that I'll get muted again. All right, so let's take a look at the flyover, and then there's an explanation of where the mission will be occurring.
Hey, Michael, it appears you have gotten muted again, and we are still seeing the link slide.
You're seeing the link slide, but not the video slide. So how do I get this to show the video slide? I'm not sure. Is there any way to have that done? It's embedded in the slide presentation. I'm surprised you're not able to see it. You hear me? Yes, Kim? Can you hear me?
Yes, sorry. I was making sure that what I was seeing was what the public is seeing. And like I said, we are currently just only seeing the slide with all the links.
with all the links, but you're not
Yes.
able to see the slide that I'm looking at. So do I need to share the screen? I guess so, right? We need to
I
share
believe
this.
that would be the
Um,
option.
yeah, let me see here. Thank you for telling me that. I'm gonna have to share then. Oh, okay. Here. There. Now, can you see it? Is it possible that you're now seeing the video?
Uh, Currently I am seeing a black screen.
Oh,
Let me check with one of my coworkers looking at the live stream.
okay. Thanks.
Okay, currently I see the Mars 2020 landing site, Jezero crater flyover. There, it has the rover with a play button over it.
Great. Let's play it. This is what I'd want you to see. For the public, this is where the mission will be occurring for the next 2 years. So let's take a look at it. Okay, so there you have the mission for the next 2 years. And now let's return to the slideshow and you can see what's going on there. Okay, so let's go there and continue with the show. I'm glad that worked. Yeah. Um, all right. So here we are back to the presentation. And there are other uh, websites that you can check. I believe that these are now available on the website. If they're not, you can always send me an email at JPL and I will respond to you. All right, let's go on then to the next part. And this is the 3D model that we can take pictures of, the rover. That is, that we can actually look at it and you can interact with the rover with the parts labeled if you're interested in finding out more of it. So I am interested in finding out more of it. So let me go to that and show you parts of it as well. I know you don't see this right now, but you will in just a moment. And I'll show you how you can play around with the rover itself, and you can check out the 3D models of it and have some fun. Okay, so let's go there now. Yeah, there it is. Okay, so here is the Mars rover itself, and you can click on for more information. Here's information about the wheels. We can move the rover. We can move it up and down. We can turn it to its side. This is all available to you if you're so inclined to look. And you can see the different parts. You can see the mast where the camera is located. The camera's on top here. If you want to find out more about them, you click there and they'll tell you that information. But they're supposedly at an average human height of around 5'9", and how you would see in vision. In this mission, we also have a microphone where we'll be hearing about the Mars winds for the first time. We'll be able to hear about them. And like I said earlier, that the primary mission of this Perseverance is to search for life. But the interesting part is that with the instruments that are on board, with the HAZ cams, the wheels, the suspension, there's several actively geological instruments: the turret, the coring drill, the pixel, the Sherlock, the Watson. These are all going to sample the soil, the ground, wherever Perseverance is, in the hopes that later there will be missions by NASA and the ESA, the European Space Agency, to land on Mars and retrieve the soil samples and return back to Earth with those samples. Now, the mission to Mars, this was a very quick mission, quick journey on this mission. It only took 208 days to leave Earth to get to Mars, which is quite remarkable. Other missions have taken months over that to reach it. So we've gotten quite good with the alignment, as you saw earlier, the way that the two planets are, and in using a more efficient trajectory to reach Mars faster. Okay, so this is the 3D, and you could spend a while looking at this. The instruments that are the arm here, and we can look at the arm and how it's going to descend, very similar to what Curiosity had. But this one will be able to dig deeper and measure the heat better. So that's what we're hoping to find. Maybe we'll find something there that proved that life did exist on Mars. That's the whole idea with the astrobiology part. Okay, so let's get back to the slides. I know we're getting down to time, but I'd like for you to personally look through your own journey and find out what you would like to learn more about on the Perseverance spacecraft. Okay, so let's get back to the slideshow, and that can be done real quick now that I've kind of learned how to use this. And so here we are. Okay, so there's a trailer here for the helicopter called Ingenuity, and I'd like to show both how the rover and the helicopter are working together. So again, we're going to go back to a site, and I need to show that to you again. So one moment, and we'll go back to that animation. Very interesting. For the first time, we're going to have a helicopter. Yes, we are on Mars. I mean, I'm not there in the control room, and you know that they're doing things that are just fantastic with what they're checking out. But as I've learned today, that they already said that the Ingenuity, the helicopter, has already made contact and sent a signal saying it's there and it's active. So let's watch this one. And this will happen in about 2 months. Unfortunately, it's not going to happen within the week or so.
Just as a reminder, Michael, unfortunately, the video did mute you.
So there you can see the helicopter. It is it's a remarkable mission because the telecommunications between the rover and the main body will continue through the mission, and so it'll be interesting to find out where they deploy the helicopter. The helicopter will then get picked up by the rover and it will be transported to a new place. All right, let's get back to the slides and what's happening. All right, so that was the full animation with both the rover and the helicopter. And there's one on, you can find online the one for the trailer for the helicopter. All right, down below there's a picture of the techs that were taking care of the mounting and the storage of the helicopter, Ingenuity, the little drone. Amazing what we're going to be able to do. Now, this is the beauty of unmanned spacecraft because we can take the newest technology off the shelf, put it into our spacecraft, harden it against the radiation and the dust and other effects, the temperature. If I could show you a blanket, the way that they coat the spacecraft to keep it protected from the temperature fluctuations and other parts of it that are used to protect. It's quite an amazing system that they have when the procedures in place to make sure these guys are dressed up in these dust-proof uniforms, the women and men together working on the spacecraft. Okay, so here is taking flight on another world. This Ingenuity is going to work well. It's hitching a ride on the Perseverance. Yeah, And you can read about this at the site. So if you go to this website, mars.nasa.gov, technology, helicopter, you will find, I'm sure there's plenty of YouTube videos on this as well now. I don't know if it shows the one where they're both together, though. Hopefully it does. You'll have to find out for yourselves. And here we are with another site for the STEM resources. That's the science, scientific, technical, engineering, and mathematical resources. For those of you who are younger ones who are watching me and want to learn more of how math is used in reaching and how the computers are used, we're using AI to get this mission to work correctly. All right, and then we have a couple more, and this is it for today. Let's conclude with the key objective, though, for Perseverance mission on Mars is astrobiology, including the search for signs of ancient microbial life. The rover is going to characterize the planet's geology, the past climate in that part of Mars, and pave the way for human exploration of the red planet. It'll be the first mission to collect and cache the Martian rock and the regolith, that's the broken rock and dust. And then subsequent NASA missions are going to, in cooperation with ESA, as we had discussed earlier, send the spacecraft to Mars to collect these cache samples and return them safely to Earth for in-depth analysis. Yep, that's our mission. And so I want you to stay tuned, and we will, if you have questions, that's the end of my presentation tonight. I hope I didn't go over line, and hope that you enjoyed seeing what we just saw. Thank you for being here.
All right. Thank you so much, Michael. We're going to have a short Q&A session now. I do already have some questions lined up. The first one I have is what are the lowest and highest temps Perseverance may see on Mars?
Oh, that's a good question. Well, remember when we first were looking here at the at the beginning when we were looking at the equipment, the temperatures. We're now. Let's go back. I want to show you the slide that shows the that clearly gives you the time that now that Perseverance is on Mars. Now, what's going to happen is that it's the springtime on Mars, so the temperatures are warmer, and actually the temperatures can reach in the summer, which will happen in March and April. We'll be getting in May, the June, July, and August. We should be reaching temperatures possibly to freezing water, to 0 degrees Celsius or to 273 Kelvin. I'm hoping that we'll get there. That's like 32 degrees Fahrenheit. That'll be the higher temperatures. But the lowest temperatures will be significantly lower, colder than Antarctica. We'll be at minus 70 to 80 degrees Celsius. And that will happen in the winter. And their winter will be in our late fall. In our fall, they'll be into their winter. So those are the highest and the low temperatures. So we're looking at relatively warmer temperatures and then colder than Antarctica.
All right. Yep. The next, there is a related asking, how long is a Martian day compared to a day on Earth?
Oh, that's interesting. Yeah, Mars rotates at approximately the same, in the same rotation as Earth, approximately 24 hours. So we get the 12 hours of near the equator of sun and 12 hours of evening. However, the inclination of Mars, it's bent further over than Earth, so it has more extreme warm and colder temperatures than on Earth. Because of that, it's more tilted on its axis than Earth, about 30 degrees or so. And we're at 22.5 or so, 22.4 degrees tilted.
Neat. Our next question was, did they test or were they able to test the helicopter in a type of chamber that would recreate the thin atmosphere on Mars?
Oh, great question. Yes. There are the big facilities on JPL where, yes, they're able to pump down the air to get the vacuum correct, put in the correct amount of atmosphere. And the one thing that they can't simulate, though, is the gravity. So we can recreate the atmosphere itself, but we're not able to do the gravity. We have to compensate for the gravity effect because Mars has about 5/8 the gravity of Earth. It's approximately a third the size of the solid of the Earth. Its mass is about a third, so it's not quite a third of the gravity. Five, did I say five? 3/8, 3/8 the gravity of Earth. And we can't recreate that.
Okay, so just so I know I'm understanding this, you're saying the gravity is about one third that of Earth, so it is less that of Earth. Wouldn't that
Yeah.
make flying slightly easier, I guess?
Good. No, it doesn't because of the atmosphere on Mars. The atmosphere on Mars is very different than the atmosphere on Earth. It's much less dense. The density of Earth, we would say, if it's at 100%, Mars is about 3% of that. And so the rotating propellers on the Ingenuity must rotate much faster at thousands of RPM in order to maintain its flight in the atmosphere. And as you saw, it's also powered by solar. So there is a way to continually replenish, but no, it's more difficult to fly under similar conditions. Yeah. And you can see it's a two propeller system to give it more lift. Any more
How
questions?
far and long can Ingenuity fly?
Oh, there you go.
How long does it take to reach?
Okay. Right here. Yeah, good questions. How far can it fly? As you saw in the animation, it'll be able to fly 100 meters or so away, possibly more. But remember, we have to be careful. There are the weather on Mars is tricky, and there are these dust devils, and there are other circumstances that the it's going to be held closer to the Perseverance, the robot itself, because of that. But it to recharge, it depends on the sunlight. It could take anywhere from 4 to 5 hours, or it could take a couple of days. We'll see. We'll see how it performs. Good question. Thank you.
Mhm. Um, uh, Another related to the Ingenuity helicopter is what is its mission or purpose as opposed to the Perseverance rover?
Well, good. Yeah, the helicopter is going to provide us a quick way to get to places where it, like for instance, the height of the, maybe it'll be able to get to the cliff, those cliffs that, as Keith said, that as Ken said, Ken Farley, that he said that the height of the ridge of Jezero in some places is up to 2,000 feet, right? This would be opportunity for Ingenuity to fly straight up, you know, and look at that. We want to look at that riverbed, as you saw earlier. Let's go. Let me just. I love this picture here of the. Let me just start the slideshow here. We can take a look at this again. This is the one. This is the picture you really want to be looking at when you want to find out about that question. Uh, we've landed near the delta. That's a done deal. And so by saying that we've landed near, we may be within a kilometer, we may be within 300 or 400 meters, but you can see here the river bed that extends to it would be to the west, almost directly west. you can see the channel that had to have been made by something, right? Which we believe was water. And that's the channel that made the delta that we are now the inner circle of the dashed line where it's Mars 2020, 7.7 kilometers. And that's where ingenuity can succeed. It can reach. It can go to those places, check out the soil, check out how dry or wet it is, and guide the perseverance to where it needs to be. Yeah, it's
Uh,
going to be something to see that. Yeah,
all right. Currently have another question.
sure.
We saw that Perseverance is going to be collecting samples, so we are going to assume that they are planning on bringing those samples and rocks back to study. How are they going to accomplish that?
Well, we're going to send a spacecraft to Mars. Yeah, it's going to be like a rocket on the spacecraft as it goes to and then have the rocket land. We're seeing this right now with the rocket missions that are occurring with SpaceX, where we're able now to successfully guide a rocket from atmosphere down to the surface and have it land successfully. Yeah, that's coming up. I'm not sure when, though. If it'll be in 2 years, 4 years. Remember, we make these missions every 2 years. And the reason for that is, of course, the proximity of Mars's orbit to the Earth's orbit. Yeah, so that's how
Oh,
it'll be done. As a matter of fact, on a less positive side, I just saw an article. I'm involved with the aerospace as well as the military technology where we're having drone upon drone, where instead of using one drone, we'll use two in order to initiate military maneuvers. So I think it's going to be similar to that. Yeah.
all right. I'm going to put out a last call for any questions. And while people are possibly typing their last questions, one question I have is you've been a NASA space ambassador for some time now. What is your favorite part of that?
My favorite part is getting the slides and the insight before others do. I'm sorry to tell you that, but when I first got involved with, thank you, Ken, for that question. It was with the Galileo mission that went to Jupiter, and I'm a physics teacher, uh, mentor, and I was at the time very involved with motion, and I was the internet was just beginning. This is back in 1996, and Galileo had a probe that entered the Martian atmosphere. As a matter of fact, it was yeah, late '95 when it entered, and that it was in November. And so I began communicating with Ron Balke of Jet Propulsion, and that part of being able to being brought in to the unmanned missions and then to gain insight. And at that time, they tagged me. I was one of a couple that we presented on Jupiter and the Galileo mission and the probe that went in. And then they called me an ambassador from Jupiter. That was pretty cool. But I did get to see the things that the the control center at JPL was seeing. They wanted me to talk about that to other people. And since I'm a public school teacher and I've taught at universities, they wanted me to continue that. And so back in '97, I was tagged, and then they changed the system to the solar system program. They incorporated into bringing in all the planets because the missions were expanding. And so, yeah, the best part is I get to see these photographs. You won't find this website. I don't believe so. You won't find this on any of the public stuff. because some of it's proprietary. I mean, maybe they should show it, but because you're so interested, those of you that attend, you're treated to these as well as me. And so I'm just passing on those background things that most of us would never know of. Only those that work there. And I think that I also get to see things that even jet propulsion people don't get to see, because an ambassador is brought in to all different parts of the missions, like the Mercury mission and the planned Venus mission. Yep, I get to see those things. While those that are on like Perseverance, they're 24/7, 12 hours per shift or more, just dedicated to Perseverance.
All right. Thank you so much. Oh, we got one last minute. What happened to the spacecraft that deployed the rover after it deployed the rover on the surface?
Okay, that went off to the side. We're going to see pictures of it. It's over, resting comfortably several meters away from the rover. Yep, it was it did its mission, and then it got its rockets and it got sent on another place. I don't know if they'll send the rover to it though, to go explore it. That may or may not happen, but you can be assured that Reconnaissance Orbiter will be taking pictures, as it did, as we saw with the entry, and we'll get that. That'll be coming out. And if you are interested, go to Jet Propulsion and sign up. Get the newsletter. They have a newsletter every day, and they send it out with what happened that day at JPL.
All right. So that's going to conclude our question and answer session. I want to thank you, Michael, for a great talk. I want to thank everyone for joining us and tuning in. Uh, don't forget to hit those like and the follow and subscribe buttons below, so you can join us again for more live stream goodness. Our next talk or live stream will be the first Saturday and that will be the What's Up in the March Sky with Lonnie Bunis. We also want to remind you that we are a nonprofit organization. We've stayed open for free public presentations and now live streams from donations from people like you. So please also check us out on our website, UACNJ.org, and our social media through Facebook, Instagram, and Twitter. We want to thank everyone again and have a good night.
Good night.